Here we are back again on the Sweet William Loco build, and here's a dinosaur in the dinosaur's workshop. I get asked quite often, why do you still use power hacksaws? Well, cheap. A couple of $100 plus a bit of freight to get it here. I think in 12 years I've put 2 or 3 blades in, and it works without me. That's the beauty of it. I can be doing something on the milling machine or talking to you, and the saw keeps on cutting. So without any more rubbish, I'll turn the thing on. And away it works. It's a Milbo 5-inch, that's 5-inch cutting capacity, made in Melbourne about the same year as I was made, and still working. No appreciable wear in the gibs, although it's probably done this particular job a million times, and I'm happy with it. Not fast, but a very suitable machine for me. Okay, back again. Just another comment about this saw for the younger guys that aren't very familiar with them. As you can see by the paint on the blade, all of the cutting has been done on the left side, and that does come blunt after a fair bit of use. So what is now the fixed jaw can be slid along the frame of the blade, so the work material is presented to the front of the blade, and you can continue to use it until it's completely worn out. As these machines are intended to run unattended, it doesn't matter how long it takes to make the cut. And it is a little bit slower at the front of the blade, but when these machines were first built, the blades were expensive to use, so you made sure you got the maximum life out of them. Back again, sir. Bit of a rundown on this part of the machine before we go. It's the second operation. Do you see the down feed? Well, I've put 1 mil depth of cut in and locked it up. There's the vice screw, luckily with the handle removed. In the background there, the clutch and gear lever, and the feed operating lever, and the knurled nut where you adjust the stroke. So swing you back to here, throw a bit of lube on, and then we'll start some more fill. As you can see, the machine doesn't even grunt, making a millimetre depth of cut. It can take several mils and it doesn't grunt. But the vise sometimes loses the grip and propels the material out. This is affectionately known as the chip box. It captures most of the chips, except for those that fly directly at me with the red hot. The tool bit is a piece of cobalt high-speed steel I bought from Victor Machinery over in USA. Prices are very, very good, and the implication was that it was an American-made tool bit, but when I got it here, it had made in China written on it. I don't mind the advertising was ambiguous, so I wasn't really thought. It would be the hardest high-speed steel I have ever ground into a tool bit, and performs reasonably well even when you're building a hard like this. I think it's about $7 per stick of 3/8 square by 4-inch ones. While that's cutting, I think I'll turn the fan on. It stinks like hell in here. Go in for a bit of a closer. I'll end today's video here because it's starting to get boring. I'll take the material down to size and hopefully next week we'll get the machine some features. Okay, all for now. Don't forget, like and subscribe. Thank you. Now that is exactly what you would expect with a roughing pass. There was a little bit of pushback on the tool and you can see that by the retrace line on the workpiece. Just there when I drag the workpiece back across. Now at the moment I'm just trying to get it down to size, so it doesn't really matter what the finish is like. There'll be other machining operations that'll take most of that away. So now I'll just deburr it, tip it over in the vise and take it down to dimension on the other side. Back soon. Back again. I had to play with the feed mechanism. Wasn't tightened up since the last bit of work on the shaper. But we're just taking a coarse cut now, ripping the material down. Now, I'll repeat the old stories. You can make anything on a shaper except money. I say BS for that. This machine works while I walk away if I want and just quietly chomps away in the background. If I had a few more parallels, I'd have 4 pieces of machine material up there, all getting cut while I'm working on the miller on the lathe. So it's a good helper. Does a lot of work you can't do with other machines. And it's mesmerising. I like watching that reciprocating motion. Take you in for a bit of a chip close up. Where these guys are winners are in long work pieces. They can scoot across them much faster than across longitudinal pieces. Of course, but yeah, do a reasonable job in a small amount of time. I could speed the stroke up a bit, but I think that this speed gives me a fairly good tool life, and I'm getting what I want out of the job, material removed. Okay, here we are. Apply a little bit of spray lube. Take it down just a little bit. There goes. Here's a bit of a video of the machine in action and the manual retract mechanism for the clapper box. It's reasonably unique, very well thought out with operating rods and fastener ball joints on the end. However, it limits the amount you can tilt the tool head. You can only go about 15 degrees either side and it has to be disconnected. So it gives you a positive clapper retract. Now set ground zero if you like. I'll wind the tool down to take about a 15 pound cut just to see it's all operating properly, and then put it back into action. I'll put you back on the other side. This is the workpiece to be machined. 2 lumps of 32 square steel on top of a couple of sets of parallels. I have put a dial indicator up in the vise on top of a parallel and checked it, and this end is 4th hour low. I'm not going to do anything about that because it's just a matter of machining this side, flip them over end for end, and I'll make something that is parallel but rhomboid. The ends will be out a little bit, and they're going to be machined later on anyway, so it won't matter. So I'll get it all tightened up and running, and we can chuck some chips. Here we have my CMZ L450 shaper, setting it up to work on some material for parts for my loco. It's a big old beastie. I did have a little Douglas 11-inch before this, and I found it much easier to use on small parts, but it definitely didn't have too much grunt. So we'll go through a bit of setting up. I'll run around all the oiling points and oil anything that slides that is not pressure fed by the pump, and then we'll see if we can't get it operating and show it throwing a few chips. Well, this has got me very surprised. All I did was reverse the direction of feed so that the trailing end of the cutting edge ended the work first, and it just come out beautiful. So we'll give it another run. I hope I've put about another thou on. I hope it doesn't go clean. Let's see. Well, look at that. This is going to come out all right. I think it's only really successful with a well-honed blade. If you try and take a thou cut or less than that, very low feed pressure, you tend to get chatter, but now I'm feeding in the opposite direction, it's cutting lovely. The workpieces will turn out just fine. And once again, this is using the high-speed steel I bought from Victor Machinery over in USA. 8% cobalt high-speed steel, supposedly made in USA, but it turned out it comes from China. But I'm quite pleased with it. It is as hard as glass, an absolute bucket of grind. So when you press it into a surface like this, quite pleased. The roughing tool I was using wasn't ground once during the whole process, so that would be about 28 minutes of cutting, and it's still in serviceable condition. Now just a wipe with the honing stone and it will be as good as the day I ground it. So good quality high-speed steel does the job. Some of the cheaper stuff is just rubbish and not really fine. Okay, won't bore you with too much more of this. I'll bring you back when we start to cut the material to shape. And here we have a good demonstration of machinist chatter. I'm going to have to change the tool geometry. It's only taking a half-hour cut, but the first half of the cut is good, the second half of the cut it just chatters. So I might give it a bit more lead angle on the edge, I think. Back it in. I'm about to take the roughing tool out and put the finishing tool in. So before I forget to show you, you can see how the tool is to the rear of the tool holder. This gives the tool more of a chance to drag and less of a chance to chatter, if that makes sense to you. The point of contact is getting closer to the pivoting point of the clapper box. The old tools were J-shaped and actually had the cutting edge trailing the position of the clapper box pin. So if the tool tended to go backwards at all, it would lift out of the work rather than dig in. And that's what I'm trying to copy. Now I'll swing you down to the finishing tool. It's quite a standard shaper finishing tool. Up, oh, a bit too close. Get it back into focus. Okay, it's virtually square across the bottom, and you have to try and get that aligned with the surface of the tool. I've ground a few degrees top rake in, and this cutting edge is tilted down at about 15 degrees, so it doesn't approach the works in a square fashion. That gives it much less impact when it first hits the job. Now I will hand stone that to try and get it razor sharp, then we'll present it up to the shaper and start doing a few finishing cuts. Here we are back on the CMZ L450 shaper, doing the last of the roughing cuts. Taking 1.5mm depth of cut. I could double that easily as the shaper's not straining, but it's hard to hold this built-in device. It does that cut across that workpiece in about 3 minutes 30 seconds, 3 minutes 25 seconds, so it's not that slow. And I'll move you over a bit closer and you can see the size of the score in the shitbox. That's been working hard. With a little 2 horsepower mill you wouldn't be pulling chips that big. I'll bring you back when we put the finishing tool in. Well, here it is, loaded back up in the mill. Hit on the head with a piece of copper and tighten that up. I'm going to be milling on the rear face of the material so that all the chips don't get thrown up at me. I'm sick of my shirt going home full of sharp things that bite the hell out of me. Put a bit of noise on. Let's see how close we can get. There we go, that's touched off. Put a millimetre in and see what it does. A little bit of grease. Absolutely painful. I think I'll look for another cutter. Well, it's a bit embarrassing. Here we are back on the same job. Put a new high performance cutter up there and away we go. I sharpened the last cutter, so I feel a bit embarrassed. This is going through it with ease. Boy, what a difference of even getting a good finish and no burn. I should listen to what I tell my customers all the time. Boy, that difference is astounding. And probably the biggest difference is in the noise. Almost ungenerated. take a bit more off. Calls for a bit more grease. Let's see how that goes. That was a good run. That's fairly close. A bit more grease on it. This time I think I'll use a bit of feed. That's making life a little easier. I'm using the layout lines to establish the dimension, and I'll come back and measure it before the final cut. What we're going to finish up here is a T-shaped section. This is going to be the axle box horns for my loco. At least this way I'm not getting splattered with hot chips, but not turning the hand. Okay, we'll take a few more cuts, then I'll bring you back for the finale. Well, hello from the old goat again. I've taken the blocks out of the shaping machine, putting up in the mill. I've got a few operations to do that are easier and faster on the mill, I will admit, but I've got to get the job done. I've got some other pressing work around. All I'm doing now is squaring it up, and then I'll scribe profiles in on the end of the blocks and put them up on parallels and move a bit of material. But we'll have it pass across. Even though this is only a turret mill, it's quite a sturdy machine. It can take a reasonable cut. The Ford International arbor gives it a bit more oomph than the smaller mills. I'll put a bit more bear grease on. Take a few more there to try and clean it up fully. As the Yanks would say, it's rinse and repeat for the rest of the work, so I won't bore you with that. We'll come back once I'm ready to start the profiles. Hello to the YouTube audience, back again in my shed with BC. This is a tool I picked up from America, Walton America number 7, and it's quite interesting. On the end of the tool, one side is ground off at an angle and the other side has a hook to retain the tool bit. So you can change the height and width of the tool slot from about 1/4 up to 1/2 inch, and this block just moves across. It's also very good in that it has divisions where it locks in at 45 degrees and 90. I'm going to be using this on the shaper. I've just formed this piece of high-speed steel cobalt blank to just under 90 degrees included, and now I'm going to put a little bit of top rake in it. I would like to hollow grind it, but at that wide an angle it's a little bit difficult. But I'll put a slide hook into the front and then we'll hone it, and it should have a very, very usable tool bit. There we are, just 3 or 4 degrees on the top, and that should be good enough. I'll put a little bit of flat on the front and I'll form that into a radius with a hand lap. Now I'm hoping I'll be able to use this to clamp the job once and come in from 2 separate directions on the shaper. Okay, back to the machine. Now onto the bench stone, we'll try and put a bit of an edge onto this shaper tool. And it's quite easy to see where you're lapping. Just brought up a reasonable edge there and there. Pull it over. And that's putting a mirror gloss on the tool. That should be quite a serviceable tool. Now this particular tool, or tool bit, I picked up from Victor Machinery in USA. It's 8% cobalt or M42, and I think they are about $7 or $8 for a 2.5 inch length. I found it to be the hardest high-speed steel I've come across. It's difficult to grind. It puts up with the work on the shaper, which is really surprising for intermittent work. The only bugger is when you get it, it's got made in China on it, not America. But not being a racist, I'll use the tool. It'll be interesting to see how that goes later today. Hello again. Just thought I'd take this shot. Brings back memories of when I first started my apprenticeship. The old fellas would say to me, don't try and find the hard way to do something. Do it simple. And here I am aligning the tool holder in the tool head of the shaper so that when I swivel the tool bit around at 45 degrees, it's pretty close to where I want it to be. I've got my 8-inch machinist square set across the jaws of the shaper. Put a parallel in between the tool block and the square, and it's bloody near perfect. Near enough for what I'm doing. So simple ways to check things. I've done some awful, hard to do, convoluted, bloody horrible things, but simple jobs like this are the ones that you want to see. Bye for now. And here we are on the other side. A little more difficult because it's the out of sight side. All I can do is move layout lines. And because I've got to extend the tool quite a bit so that the tool holder will clear the vice body when it gets down to full depth of cut, I can only do light feed rates. And as the Yankees say, rinse and repeat. It's coming out in reasonable time for something that's going to be hidden on a loco. Out of sight, the finish is acceptable. And I don't have to sweep up much, except for the big curly weeds that land on my knees. They soon wake you up if you're half asleep. Okay, away we go. Back for a quick clip. I've left the shaper running so you can see the action of the clapper box, but also the orientation of the tool holder. I've got the high-speed steel bit behind the axis of the tool holder. That helps to stop chatter and prevent it from skipping. You can also see there's a little slot in behind the tool bit where I can pour the oil in, and that guarantees it gets down on the job. Okay, that's it. Well, hello to YouTube and the viewers. Welcome back to In My Shed with BC. This is a further episode of making the locomotive axle box horns. This is the second piece of material, and I've set it up in the shaper to compare to milling operations. You can see the tool that I ground to just less than 90 degrees is tilted over reasonably accurate to 45. I've just done a test run, and my only problem was keeping lube up to the tool, so I went back through memories of what an old bloke said, and he feeds the cutting fluid to the tool and lets it run down the tool bit. So you're trying to get at the pointy end where things get nasty. So far everything's running quite smooth. I'm only taking about 1.5 mil depth of cut. This one I've turned back to about 0.5 mil to see how that goes. But first thing I notice is it's not swarf all over the place. It's all getting caught up in the shitbox like it should. Okay, we turn the power on and we'll do another run. I'm manually feeding it downwards with the hand wheel. So far no dramas. I just hope I don't have the slip when everybody's watching. Okay, power up. Nothing's happening. I'll line it across it. a bit of this out, I think. A little bit of smoke so something's getting cut off. Just bring up a pretty good finish now on a fine cut. Down feeding about 6 to 8 tag per pass. For a bit more. That's more like a shaper cut. Just have to make sure I don't get overzealous with the downfill. The disaster would only be short-lived, but it would be a good one. Surprisingly today the tool isn't throwing chips at me, probably because it's a lighter cut than I usually take with the shaper. Interesting thing to note is that the time taken per pass is not that much different to what it is in the milling machine. Okay, wind it up again. And I'll give you a bit of a rest while I take the rest of the material off. And at last a finished product, which took more time, the mill or the shaper. Well, they both take a lot of time because I'm setting up for the first time and figuring out how I'll do it. Actual machining time, it's fairly close. Not that the mill is slow, just that I don't have good tooling for it. All my index LM mills are low horsepower, and it's not a really rigid machine for hogging material off, but even if I could hog the material off, how the hell would I hold the thing to stop it flying across the room? So I'm happy, halfway through this part of the project, then cut them all in half and start on a bit more. Bye for now, like and subscribe. See you later.